Let's turn our attention to network address translation in this section. So NAT, or network address translation, within pFsense features a default outbound NAT rule of all internal traffic. So any traffic that flows through its interface, including downstream traffic, so traffic that could be handled by subsequent, so let's just say, i.e. subsequent pFsense or other routers / firewalls. So anything that traverses the pFsense interface will be NATed automatically. Again, if we take a quick look at our dashboard, our internal interface, we've lost our session in that time. Let's go ahead and rectify that. So our internal interface is LAN interface is 192.168.1.1. Any traffic on this network and subsequent derivatives of this network were connected to the LAN interface. Once they traverse the LAN interface, will be automatically outbound NATed using the IP address associated with the WAN interface. So default outbound NAT for all internal traffic, so on and so forth. Default NAT outbound uses external IP address configured or assigned to WAN interface. And the WAN may in fact connect to some other LAN. Just the external interface is what's important. So that is the default behavior. And we've already seen that by attempting to initiate connections from the LAN to the quote-unquote WAN, a node on the WAN, and we saw the address show up as 75.3. So that should come as no surprise. So that means if you drop pFsense directly into the edge of your network, interconnecting your LAN to the edge, then any edge address, which is usually a public address, will be the outbound NATed address that's used for routing traffic. Additionally, one-to-one mappings are supported. So the relationship between, say, one external or WAN address and one internal or LAN address. So with the aid of virtual IP addresses or any type of address that may be bound to the external interface via CARP, virtual IP, etc., you can tie those IPs to internal nodes and create one-to-one mappings, which means the whole port range becomes available within a specific IP address between an external address and internal address. That's often desirable for nodes that use specific features such as SSL, maybe even IPsec, and so on. It's quite possible to do so. And we have addresses that are free. For example, 75.3 is the existing external, but we could tack on 4, 5, 6, 7. Any address that's available can be associated with the WAN interface and subsequently be mapped one-to-one to an internal node. And very core or basic functionality would be port forwarding. So essentially, this forwards external port requests to specific internal nodes and ports. So a simple IE of this would be send all SSH traffic, so maybe on the external 192.168.75.3, which is the WAN, SSH traffic to maybe 192.168.1.102, our Ubuntu instance port 22. And similarly, we could extend other ports. If we had no other IP addresses, we could maybe do 192.168.75.3.22.22, maybe send that to 192.168.1.103, which is a BSD instance, to its 22. So we do have some flexibility, but of course you'll have to have a means with which to keep track of these port relationships, but you can forward ports. Currently, ports 80 and 443 are forwarded. So let's say currently TCPs 80, 443 are forwarded to the firewall itself, but we certainly can forward to other IP addresses as needed. And yet another feature supported is NAT Reflection. This is important. This is the ability to access NAT addresses, which of course are external, from the internal, which is usually the LAN interface. And let's just note that this obviates the need for split DNS configuration. So i.e., let's say internal FQDN resolves differently, let's say from external FQDN. So to further elaborate, a request, let's say, to a resource that's really on the LAN. So let's say we had a web farm.linuxcbt.internal with split DNS from the inside would resolve a different address from the outside. So from the inside, it would be, say, 192.168.1. Maybe let's say 102 is the host. So this is an internal resolution, whereas maybe 192.168.75.3 or some other address 4 would be an external resolution. And that would give us a split DNS configuration. So you'd have to either use the same DNS instance or separate DNS instances to keep track of the different addresses. And pFsense supports split DNS configuration, so that's possible as well. In fact, it's the suggested way of presenting IP resources over NAT Reflection. But NAT Reflection is useful because, again, it's common that your DNS contains information pertaining to the real address, the NAT address of the resource. So might as well allow traffic through the firewall and back to its NAT address to provide access. So let's say we have a look at some of these areas. Let's look at the default configuration. As we already understand it to be that it NATs the external address, let's see how that's set up. So to find all of this, we navigate to Firewall, and then NAT, and we can take a look at the different policies. So let's see what's happening here. So let's go to Firewall, NAT. Here we see the port forwarding configured to nothing. We can add a rule if necessary. We'll do that shortly for SSH, for example. 1-to-1, nothing's currently mapped. Outbound defaults to an automatic outbound NAT rule generation, which uses the external address associated with the WAN interface, but can be overwritten if you have additional IP addresses defined. MPT deals with IPv6 mappings. So how do we, let's say, force the mapping to a different IP address? How do we change, say, outbound rules to map to, let's say, a different address such as 75.4? So let's say we bind new virtual IP and map outbound traffic to that address. Let's say we use the address 192.168.75.4. Before doing so, let's be sure that the address is available. We'll send some packets, which will of course test ICMP, and if it comes back as down, we'll assume that it's available and use that address. So first we need a virtual IP. Let's add a virtual IP as our first step. Otherwise you're not able to use the address. So first, add virtual IP. Let's go back to our config. Firewall virtual IPs, and we'll go with virtual IP as opposed to CARP, which allows us to do redundancy. And it'll be on the WAN interface. You can specify the interface that's of interest. It can even be a virtual address on the loopback or localhost interface. So it's going to be an IP alias, virtual IP, single address. And let's make it 75.4. You can also add an entire subnet if you'd like using one of the other protocols. And this will be just for that specific node. Normally when you add a specific node, it's a /32. A specific IP, that is, to the node, it's a /32. No passwords necessary to use the IP address between, say, different pFsense instances. And as a description, you can leave it empty or just put something as maybe outbound NAT maybe 1 or something along those lines, and maybe more specific as you designate it to different purposes. So this will bind 75.4 once we've applied the changes. And we should now see that new address show up if we try to access it from the shell. We've given it a description of Outbound NAT 1. Let's move this over just a tad. And let's try to access that 75.4 address. And as you can see, 443 and 80 are accessible. So what ends up happening is the firewall binds to the IP, and any ports that are accessible for accessing the firewall itself become accessible on that address as well. So add virtual IP, and then test access, and just note that ports that are mapped for pFsense access become available also on the new virtual IP. And that's always the case. It's a default configuration. It can be overridden, but by default, the firewall will listen to all those IPs, such that if you now try to hit 75.4, you'll see that it pops up and asks you to log in. The 75.4 connection differs from the 75.3. A maximum of 2 sessions are supported currently, so we could open 2 separate sessions. And that's the new address, but it's not being used for Outbound NAT. And that we can confirm by trying to source traffic, say, back to one of our nodes. So let's say we open this up for a moment, and on the BSD node, let's telnet maybe to 75.101 on port 80. So that opens that up. Pop back over and just confirm what the current state of the connection is with a netstat ANT. Grep 80, and you'll see 75.3 persists. So to influence the Outbound NAT, we need to create an outbound rule that maps traffic to 75.4 as opposed to 75.3. So we need to change the rule from automatic to manual. So bind new virtual address, map outbound traffic. So let's say we change or create first an outbound rule, outbound NAT rule, to map to 192.168.75.4. And then we'll follow that up with a change of auto to manual in the NAT policy. So in NAT outbound policy. And then, of course, test. So test communication. So let's see what's happening here. So as we can see, firewall NAT outbound automatic uses the default IP address, and it will default to the first IP address, 75.3 as opposed to 4. So you create a rule. The rule can be based on a wide variety of criteria. So you specify which interface the rule applies to. It's usually the WAN interface. You can tell it which protocol or any protocol. So for example, you can NAT traffic for TCP differently from UDP, or TCP UDP differently from ICMP, or either of these differently from any of the VPN protocols or CARP or pFsync protocols. So you can split the traffic out nicely. If you go with any, that means any traffic source that meets a criteria will be NATed as 75.4. So, and by the way, once you set up the NAT, then you drop access to the standard. Once you override these settings, you drop access to the standard ports 44380 for pFsense firewall management. So the source, well, which network should be the source? It should be the internal LAN network of 192.168.1.0/24. You can even map based on a source port. This is source NAT routing. So if a traffic comes in on, say, DNS or NTP, or usually the UDP ports, which are predictable, maybe DHCP, etc. for relay, then you can force it. Otherwise, you leave it blank, and any port will fulfill the criteria. Any protocol, any port coming off of the network 192.168.1.0. And of course, these are just fields that are part of the TCP, UDP, IP headers that are associated with each packet. So the firewall will parse those out as needed. You can also set the criteria based on destination. So supposing when traffic's destined to the 192.168.75 subnet, it should use this rule, versus when destined to the internet, it shouldn't use the rule. Maybe it should use 75.3. So those can be influenced as well. And on the edge routers, that might be important. So you may say, if accessing, let's say, some parts of the internet use one address, or if accessing some ports on the internet, maybe 8443 use a specific address versus maybe SSH or some other protocol. Otherwise, the rule applies to all destinations, including internal resources, which are considered the WAN interface for this firewall. And it translates it to an address that you specify, 75.4, or the interface address. The default rule already does the interface default address of 75.3, so what we want is 75.4. And you can also do whole networks as well, so you can map a range of internal addresses to a range of external addresses. And you can give it a description. Let's say all to 75.4 or something along those lines. And then save the rule. Now this doesn't make the rule, or it doesn't affect the rule, it doesn't create this change automatically. Automatic will still use the default configuration. It's when you go manual, but let's just confirm that. So now we have this new rule of 75.4. Any traffic coming off of, and this whole row represents criteria, so any traffic coming off of 192.168.1.0, map it on the WAN interface to 75.4. So let's go back to VMware and let's try to create a new connection here. So still port 80, pop back over and confirm using netstat to see what's happening here. So notice new port 1994 75.3 is still the port of the day, and you can vary the ports, so it's not a question of if it's port 80 versus say port 22. Doesn't matter. Any connection you source will still use that default address. So now we look for 22 and you'll see that it's still 75.3. So that's the default behavior. Now to make this the default mapping, change the automatic mapping to manual mapping. By changing to manual outbound NAT, the rules on this list are processed. Otherwise, automatic uses the external IP address associated, the default IP address associated with the interface. So we want this to be manual so that the rules are honored. Otherwise, you can build your rules list and they'll simply be ignored. So let's see what happens now when we source a connection after having made the change to a manual outbound list. And also, by the way, when you do go manual, be sure that you have rules for all conditions. Otherwise, you may inadvertently drop outbound connections. So this is why our rule matches most criteria, because it's just to any destination based on any type of traffic, TCP, UDP, so on and so forth. So now let's see what's happening here. Let's see where our established connections are for 75. We should see something coming in. Let's see if we've done this on, actually it's on 22. There it is, 75.4. So it's buried in the list. So it's come in on 75.4, coming out. And that's working as expected. And of course, other resolution types should continue to work using this address. So for example, when you perform DNS resolution off of the pFsense instance itself, that uses the internal address. So for example, cat etc resolve.conf uses 192.168.1.1. So obviously that's going to use the internal address of 192.168.1.103. So that doesn't require a NAT. But if you do decide to NAT, say specifically at 192.168.75.101, which requires NATing, let's say for a node such as linuxcbt.com, this will translate to 75.4 to perform the request and return the result. So that comes back nicely. And of course, access to resources on the net will continue to work. So if you telnet, say, or nmap maybe port 80 on, say, dev1 linuxcbt.com, it first resolves it and then searches to see if the port is open and then comes up accordingly. And so long as the edge router has a route back into this network, it'll continue to route the traffic back in. So that's a simple outbound NAT rule. But again, the caveat, just be mindful of the fact that you need a rule that's as generic as a default outbound rule. So let's just note, ensure that if you use manual outbound NAT rules, let's just set this, that you have, let's say, at least one generic all-encompassing rule to cover, let's say, common traffic types. Otherwise, traffic will be blocked. And what's an illustration of that? Well, for example, let's take a look at the firewall. Supposing this rule is based solely on or exclusively on a destination port of, say, 80. So if traffic's leaving the network destined to port 80, map it to 75.4. So what happens to the other traffic? So you edit this rule, and you set the destination port to, say, 80. It could be any network. Doesn't have to be our local. And you'll see that the rule was created in this time, updated this time, and it'll be updated momentarily, and we'll apply the change. So now the criteria have been updated to include a destination port of 80. So what does that mean? Well, let's go back over. We've yet to open 22 going in. So let's see if we can do 80 on dev1linuxcbt.com. That looks good. Now what about port 22 on dev1linuxcbt.com? So this goes to scan port 22. Let's try to do it on the internal node. Let's say 192.168.75.101. And it comes back that it's open. Let's telnet to 192.168.75.101.22. And let's leave that open for a moment and pop back over to see how pFsense has natted the connection. So netstaff ANT grep 22 now shows that the traffic comes in. Let's see where it's mapped out. 75. This is going to be grep 22, 75. This is 87. That's a wrong connection. 7592. 1.102. This is our connection going in. And let's see where it's coming back. Let's see what it's got here. Let's see if it dropped the connection. Let's pop back in over here. The connection's still open. Actually, CBT build 1. That's looking good. Let's try it again. Since the rule's written for 80, and let's pop back over. And that should be 103. So we don't see any instances there. Actually, we do see 192.168, 1.103, time wait, 1.102, outbound 22. But we're not seeing an instance coming in. We see 75.87. That's different. 92. Those are internal nodes, but no evidence of 75.4 or 3 connecting on port 22. Let's check 80. That's just the listener, so nothing's coming in. And there we see the establish of 1.103. So what it's doing, it's actually, so this is at the bottom of the list, so it's actually not natting it. It's just allowing it to route. And because the node 75.101 has a route back, it allows it in. So let's just note, ensure that humanity that you have at least one to cover common traffic, otherwise traffic will be blocked, or let's just say may be blocked. May be blocked or not translated, which is what we're seeing. So i.e. 192.168.1.103 making a connection to 192.168.75.101 port 22 is not natted. And that may end up being blocked in the event that you try to leave your edge network, or if there isn't a route back to the source network. So in this case, we're not getting a NAT, but if we tried, say, port 80, you'd see that it NATs it to 75.4. So let's pop back over here just to confirm that. So things are just working here just because we have a route back in and the RFC 1918 address is permitted. So let's connect to port 80. Let's go back over here. Now we'll search for port 80 and you'll see it's natted to 75.4. And that's because the rule covers one destination port. If you edit the set, take a look here. So destination, port 80, it's for a single rule, single port. It isn't accepting a list per se. And it maps it out as 75.4. And you can even force it to a source port if you'd like. And the destination could even be a specific network, such as 192.168.75.0/24, which means it would block traffic going out to the net or send it out as its true address, 192.168.1.103, in the event that there's a route back and there's no blocking of RFC 1918 addresses. So this is a specific rule for a specific port. All else is up for debate. If you take that port out and update the criteria, then it should fix matters such that it maps to 75.4. Let's apply the changes and try to do that again. Let's try to make that connection back out to 22. and confirm that it's actually routed with a netstat. And there you should see 75.4 coming in, whereas this is a connection from 101 to 22. That's why. So two different connections. So the changes have been applied. Now that's on the outbound side. And if you have additional IPs, you can map them out using different addresses. So for example, let's say we add firewall virtual IPs. Maybe we add 75.4. And by the way, when you have a rule, you can normally duplicate a rule based on an existing rule by just clicking on an add. But let's do an IP alias. And we're going to make this 192.168.75.5. That'll default to a /32 because it's a single address. And this can be anything outbound, maybe NAT2 or something along those lines, or NAT in the port. So outbound NAT1, outbound or NAT2, either or. So this gives us a new address momentarily, 75.5. Then we decide to create a rule in NAT on the outbound side, since we're using manual now. And maybe we'll update this rule to be for port 22. Let's make it in order of port ascending. And if you want to duplicate or make a rule based on the existing rule, just click on add and it'll pre-fill the criteria for you. Make this port 80, for example. And this time we'll make it 75.5. And that'll split off the outbound traffic accordingly. So we have the two rules in. If 22, use 75.4. If 80, use 75.5. Apply the changes and then back over to the node for a moment to see how this plays out. So we'll kill this session and tell NAT 22 that should use 75.4. And let's pop back over, confirm it. So there's 75.4, a new session open. The other one's timing out. This one's open. And then let's pop back over. We should see 75.5 for port 80 access momentarily. Let's try to kill this session here. Port 80. Let's grep out 80, and we should now see 75.5 comes in. So you can split the traffic that way if you have the IPs to spare, or if for some reason you're tracking. Maybe wondering why would you do this? It's largely for tracking. It's largely just to keep traffic organized. So let's say repeat with additional address and split, let's say, destination TCP 80 from TCP 22 and evaluate and see how it works out. So of course you can do that. You can do it on a port basis. Let's just know that this may be ideal to help track discretely, of course, traffic destined to various targets. So you may just have a chart or some sort of document that helps you to track the traffic in your environment. It just helps if you're able to map these things out accordingly. And if you have spare IPs, you can also do one-to-one mappings. So let's say making a distinct relationship between an IP and, let's say, an external IP and an internal IP. So you click on add, for example. So the WAN interface, let's say 75.4 should be mapped maybe to an internal IP of 192.168.1.102. That's the Ubuntu box. Any destination, let's just say inbound 102 for some reason, just to map it out. And you must make the changes in order to take effect. So now 75.4 should map to the 1.102. Now, how does this impact the rules? How does this allow us to access the node? So, for example, what does that mean in terms of accessing pFsense versus the node itself? Well, let's first try to access pFsense on 75.4. So 75.4 finally times out. It just took a little bit for the firewall rule to reset. So let's say here 3 one-to-one mapping. So note, disables pFsense access on the one-to-one address or addresses. So that we've confirmed. So map one-to-one 192.168.75.4 to 192.168.71.102. So that we can confirm. Now, try to access services on that address 192.168.75.4 from, let's say, the WAN perspective. So what does that mean from the WAN perspective? Let's nmap 192.168.75.4. Let's see what it finds. So it says 443 and 80 are accessible. So what exactly is coming up? Is that 80 and 443 on the internal node, or the internal protected node, or the firewall itself? So 75.4 comes up with it works. But which server is this? Well, to determine which server it is, let's do a telnet 75.4.80. That opens a socket, and if you just kill the connection, you can often tell what type of server it is. Method not implemented. So far, nothing. Let's see what it's doing. 75.4, telnet 80. Let's keep that session open. Now let's navigate over to that node, 1.102, which should be this node here. Let's just break this session out and see what we can come up with. And of course it's losing its context. So let's see if we can pop off and come back in and see if it'll pick it up. And we'll just give it a bit. We've had this difficulty before. It doesn't update the screen often enough for VMware to pick it up. So you just have to oscillate. So let's see if that connection's still going. Let's grep port 80. So let's see what we've got. 75.101, port 80. And let's pop back over to see the connection's already dead. So 75.4 to 80. That's the problem with these connections. The servers will time them out rather quickly. So there we see the connection, 75.101. So we know that the connection to 75.4 is being mapped to that particular node. How is this all working? We haven't written any firewall rules because there are generic rules already defined which cover 80 and 443. Let's just go back and take a look at that. So try to access services. Let's just note that TCPs 80, 443 are now accessible because generic firewall rules exist to forward both TCPs 80 and 443. That's why it's working. So that begs the question, why not just open up SSH, which will ultimately prove whether or not we're hitting the right server? Well, if 75.4 were the firewall, and access 75.4 would 1, rewrite the connection as SSL, and 2, show us the pFSense screen. So if we take a look at firewall rules, what you'll see, these two rules with any source port to any destination, so long as the port's 80 or 443, will permit the traffic to pass the firewall's WAN interface. So the firewall rule in conjunction with the NAT rule determines where the traffic ends up. And that's always the case on these types of firewalls that support NAT as well as firewall rules. So let's just note that, just to reiterate this, that the firewall rules in conjunction with NAT table determine the ultimate destination of traffic. So what's happening here is the firewall sees destination ports of 80 and 443 and allows the traffic to pass. But then the NAT table says, well, if that traffic is coming into 75.4, redirect it to 1.102, and that's what's happening. So that ultimately means if we have a firewall rule for SSH, so we can copy one of these by clicking on Add in the lower right-hand corner, changing HTTPS to say SSL, then the traffic will be routed accordingly. So let's say, or to SSH that is. So SSH to SSH is a rule. This becomes SSH access. Now this is a generic SSH rule for all the nodes behind the firewall. So if there's a NAT for SSH for any other nodes, it'll work. So now any node coming off of 75.0/24 with any source port heading to any destination, so long as the port is 22, will be passed. And then the NAT rule ensures that there's a one-to-one mapping. Let's pop back over here between 75.4. So if you hit 75.4 on port 22, 22 passes, but .4 criteria says send the traffic to 102. So now Let's see, after we've accessed services, that looks good. C, open floodgates to allow TCP 22 to 192.168.1.102 and test. So now we should be able to SSH. Let's say we open another shell here coming off of any of these nodes. And in fact, even from this local node, let's do a netstat.rn and see if we've got our route into 75.3 and 75.3 EM0 or 192.168.1 that is. So 192.168.1.0 through 192.168.75.3. So let's see what we've got. Let's try to ping 192.168.75.4. 3 doesn't come back. It's not allowing ICMP. Let's try to telnet to 192.168.75.4 port 80. That comes up. And let's kill this and try to hit 22. And that comes up. Debian Ubuntu. So you know that's a target. And that means if this comes up, we should then be able to SSH. And we don't actually need a route because we're not trying to access the one address, but just the externally NATed address. So let's SSH to 192.168.75.4. And momentarily, this should pop us over to that node. And if we copy the keys, I'll just expedite our ability to connect to the node. So let's see what's happening here. And now we're on ubserv 1, netstat.ant. We should see that we're connecting in from 75.101 to its port 22 because it's routed accordingly. Now, for other types of NATs, we've said you can use multiple ports. So there's a BSD box on the same IP address, that is. There's a BSD box that also has SSH, and unless we use a 75.3 address, we have no means with which to connect to it. So for example, let's drop back for a moment. Let's say we try to SSH to, or telnet to 75.322. It doesn't come up. There isn't a mapping which allows it. So there's a one-to-one for 75.4. We don't want a one-to-one of 75.3 because that would drop access to the firewall altogether. So the question becomes, how do we forward ports, specific ports? Well, you have to spell out those ports individually. So if you want 75.3's 22 to give you access to a specific internal box, such as BSD1, then do a port forward. So on the WAN interface, TCP, the source can be anyone. The destination needs to be a specific WAN address, which is 192.168.75.3. That is the WAN address. It is the first address. Or you can put it to the 4 address or the 5 address, doesn't matter. But the 4 address would have a problem because it's a one-to-one mapping. The destination port, we want it to be SSH. So let's find that on the list. SSH. And the redirect target IP is the internal node, 192.168.1.103, which is the BSD box. The redirect target port is the same port, SSH. Common ports are listed, so you can just either spell it out or indicate it from the list. And let's just say SSH to Unix CBT BSD1. And that'll give you SSH. Now, the NAT Reflection, the default is disabled. So from the internal perspective, you won't be able to access this address unless you enable it. And let's click on Save. And the following errors, invalid characters detected, SSH. It doesn't like the description. Let's drop that out. So SSH to Unix CBT BSD1. And the NAT configuration has been changed. So now we have a port forward on the WAN. If destined to 22, send it into 1.103. So let's see what happens here now if we try to telnet to it. There it is, and you can tell already it's FreeBSD, in a particular release, 10x, etc. Which means if we kill this session, we should be able to SSH into it. But let's just confirm that we can still get to 75.4 on 22, and that's Ubuntu. So we know it's working. And to overall confirm it, let's SSH into 75.3, and we expect it to come up. Now, it doesn't have a user called Linux CBT. It has one called Unix CBT. So let's just connect as root to avoid any problems. And there we have a session on. And of course, we could do a netstat.amp, TCP. We'll see the sessions coming in off of 75.101. So that's working. Those are TCP listeners. So that's working. That's a one-to-one. So that begs the question, what about just using one-to-ones rather than, or why not just do port forwards as opposed to one-to-one to conserve resources? So you could do 22 for your main box, maybe 22 for another box. in which case drop the one-to-one mapping. So for, or maybe D, remove one-to-one mapping and use port forwarding. So actually we'll make that E. So port forward 192.168.75.4, which is the firewall's IP used for administration, along with 3.22, as well as for outbound NAT, to 192.168.1.103. Remove one-to-one mapping, and then repeat. So we'll have something like this. But this time it's going to be 75 forward, maybe 22.22. As long as you keep track of it, it's not a problem, to 1.102. That'll conserve resources. So let's take a look at this mapping. We'll dump it, and that'll kill any SSH sessions once you apply the changes. We can confirm that from the shell trying to telnet into 75.4. So that's gone. The firewall rule still exists. Just to be clear, let's go back to firewall rules. We still allow SSH traffic to pass through, but there must be a NAT. Whether it's a port forward or a one-to-one, there has to be a NAT in place to allow traffic from one interface to another. So we can port forward that. We can copy this rule and just change the destination port in the packet that's received to something specific. So it's not going to be SSH anymore. It's going to be a specific request to maybe 22.22. And send it into 102.22.22 and make this other. And this is going to be SSH to Linux CBT Ubu serve 1 on a non-standard port, but that's fine because the SSH client can be configured accordingly. Let's apply the changes. So now any request to 22.22 will magically end up at 1.102. That can be confirmed by doing 75.4, 75.22.22. And this should kick the traffic over. Let's just double check our ports here. This is going to be port forwarding 22 goes to this one, 22.22 goes to 1.102, 22.22. We have an extra port here. This is not valid, actually. It should be 22.22. Actually, this is the one redirect target port. This, the form field should check because there is no such port as 22,222. So that's a bug. Let's click on apply changes there. So note current web configurator allows specification of invalid target port of TCP 22.222. So be sure to indicate valid port within the 16-bit range. So let's see what we've got going on here. 22.22. Let's kill this and try it again. 75.4, 22.22. Let's see what's taking so long. This should be WAN address, destination port 22, TCP. This should be 22.22. This should be 22. We're actually mixing up our ports here. Direct port should be just 22. So this is just SSH. So we're confusing the input. Let's make this SSH and save it and try it one last time. It should work this time. Let's kill that. Try it again. It just takes a bit to reload the rule. And we'll try it once more. Actually, it's going to be on 75.3. We keep hitting 75.4. And let's make a space here. That's more like it. So now it's connecting to the Ubuntu instance on 22.22. Let's kill that and try 75.3.22. That's going to connect us to the BSD box. Again, this is working because it's doing a port forward on the WAN address. If we change these to 75.4, then what we were doing would work, with the exception of the incorrect port that we had placed there. So this should be 75.4, which is used for outbound NAT. Let's click on save here, as well as modify this secondary rule. You can manipulate changes wholesale as well. 75.4, save the changes, commit them. So now they'll respond on 75.4 as we were testing. So 75.4, 22.22 gives us Debian, Ubuntu, and then 22 will give us FreeBSD. That looks good. So those are port forwarded items which save resources but require that you specify different ports, and that's not a problem. You can specify the SSH port rather easily. One-to-one wastes an IP, but that's sometimes required. Outbound allows you to route traffic based on criteria. It's always safe if you go with automatic and just use the external IP address, but sometimes it's required otherwise. If you flip this to automatic, the rules are ignored. Let's go ahead and click on save. I'll just resort to 75.3, and we'll leave that rule in for the moment, or those two rules in for the moment, and you'll see that it'll just revert to 75.3. And the internal side differs from the external side. So outbound will use 75.3 automatically, but inbound requests to 75.4 will continue to behave as we expected. So there's BSD, and let's just make sure that we get the other node up, Ubuntu. So they're both there. So the outbound side and inbound side differ, and that's how it works. So the natting is rather straightforward. The criteria are pretty straightforward. You can indicate what's necessary. Sometimes you should one-to-one. The outbound criteria will be driven based on how you route traffic in your environment. So depending on the characteristics of the packet will determine if it should use address A versus address B. In order to use addresses, you should look at the virtual IP section and bind IP addresses to the interfaces. Wherever possible, remove addresses to conserve resources, so we're not using 75.5. If you drop an address that's tied to a rule, that breaks the rule. So if you kill 75.4, the traffic won't come in. You'll have to switch the rules to use the WAN address. So let's say you kill this, try to kill it. It knows that it's being used by a NAT mapping, so it doesn't allow you to. So you'd have to actually change the NAT mappings using 75.3, for example. So let's take a look at our NAT. These two would need to be manipulated to use the WAN address as opposed to the other address. And then you can update the changes accordingly so that it makes it what we want it to be. Let's go ahead. Actually, selection is usually for the movement of the rules. So you can select multiple rules and move them around wholesale, which makes it much easier. So the interface address, let's find that's going to be 75.3, which is just the WAN address. Let's apply that. Modify this as well. Make this the WAN address. And we'll confirm that it works before we clobber the address. Or maybe we'll clobber the address first and then confirm that it works. Either or. Let's take a look at our virtual IPs here. So now we should be able to clobber this because no rules are using 75.4. That looks good. And then let's try to connect. 75.4 fails as expected, but 3 will work. That's Ubuntu. And then let's try 22. That's FreeBSD. So you can tweak these rules in and out as you see fit. It's rather straightforward. You just have to play with it. But normally what I like to do, and what's probably the best way to move forward, is to plan your rules in a way that corresponds to your drawings, your network drawings, usually Visio, and spreadsheets, and document these things before you actually implement them, and of course test them before you implement them. Let's also add one more rule to cover a box that we haven't worked with yet, and that's the Windows box. So add, or let's say port forward. And this should be that. Let's say TCP 3389 to 192.168. Actually, its address is currently unknown, so to Windows box. So what we'll do is we'll have a port forwarded rule momentarily, firewall rule for 3389. And let's click on add. Actually, we'll just add it based on this and just modify it accordingly. That we want to be an RDP rules. So let's see what we've got here. It's going to be, instead of SSH, Microsoft Services, MSRDP. And the internal address, let's say it's going to be 104. Although we don't know yet, but we can always modify it. And this is going to be NAT RDP to Linux CBT Win2. Once we know its address, we'll fix it. And then, of course, you can make the addresses static to allow traffic to flow. So there's a rule for 3389. Presumably, we'll go to 1104, but you can always create a NAT entry that matches the firewall entry. So firewall NAT port forward TCP 3389, send it to what we presume to be 104. So we just double this up, change this out to MSRDP, and that should set that and presume it goes to 104. If the address changes, then we'll update it accordingly. And this is going to be RDP to Linux CBT Win2. Again, we're working with simple rules here. No need to complicate matters. Rules can grow into the hundreds or thousands and become convoluted. So if the address is not 1104, then we'll update it accordingly, and it'll be mapped so that we have terminal services access. So let's move on.